Welcome back to Miss Eddie's Math Movies, where it's a cute to be a square. Today's lesson is 5.7, Reflections and Symmetry. By the end of the lesson, you'll be able to identify reflections and lines of symmetry. The second kind of transformation we're going to learn about here is reflection. We just learned translation, and translation is a slide. Now we're learning reflection. So a reflection is a transformation over a line of reflection that creates a mirror image. And the line of symmetry is basically a perfect fold line. If you could fold something in half perfectly. All right, it's like a line of reflection in a shape. Line of reflection within. All right, I'll give you some examples. So we'll draw a smiley face here, and we'll call this the line of reflection. So we're going to reflect this smiley face over this line. It's going to look like this. So this is a reflection. Now, a line of symmetry is a perfect fold line. So let's take a look at an isosceles triangle. This is the perfect fold line. You see how this half is exactly the same as this half. That's a line of symmetry. So certain things you need to know about reflections is that the reflected image is congruent to the original figure. This smiley face and this smiley face are exactly the same. Same thing here. The orientation, though, is reversed. Things will be facing a different way. That's what that means. And the line of reflection is the perpendicular bisector, which we just talked about. I'm going to show you what that means. So, the line of reflection, this line right here, cuts all these distances in half. The distance from this top of the shape to this top cuts that distance in half, cuts this distance in half, and this distance in half. That's what that means. All right, draw the line of reflection. This is what I want you to do now. Pretend you're flipping it over. You're taking this E and you're flipping it over this line. So that's what I want you to try. See how you do. Tell whether the gray figure is a reflection of the black figure. So we're going to go through these 3 steps that we just learned. Is it congruent? Is it reversed? And are the lines making perpendicular bisector? All right. So are these 2 shapes the same? Yes. Did they switch directions? Did the orientation get reversed? Well, this one's kind of pointing up and this is pointing down. So yes. And if you connected the corresponding points, does this line cut those in half and make right angles? Yes, it does. So the gray triangle is a reflection of the black triangle because all 3 properties are met. All right, what about here? Did this gray triangle get flipped over to turn into that darker triangle? Well, they still look the same. They're still the same triangle. They are congruent, but are they facing a different direction now? That is no. They're not pointing different ways. Are the lines connecting them being bisected? That distance is definitely not the same as that distance, so that's no. So this is not a reflection because the orientation is not reversed. This is a translation, which we learned about. It's a slide. So this is a flip, this is a reflection, This is a slide, which is a translation. We were looking for this. Oh, here it is right here. Name the transformation. That was a translation. It was a slide. All right. Which segment is the reflection of AB in the x-axis? When you see in, I want you to think over. Which point goes with A and which point goes with B? Okay, let's look at AB. Here's AB. If we were to flip it over the x-axis, so we were to take this and flip it over this line, it would flip onto JK. But what point does A go to and which point does B go to? Well, A would flip down. If it's one away, it's going to go one away. A is going to go on to J, which is -4, -1. That means B, look, B is 1, 2, 3 away from this line, so it's going to go 1, 2, 3 away. B is going on to K. K is at -1, -3. So look what happened to the coordinates. All that happened was that the Y changed signs. Okay. So when you flip over the X, the Y changes signs. Let's check out this one. What if we flip this over the Y? If we take AB and we flip it over the Y-axis, it's going to go on to ED. A is going to go on to D, which is at 4, 1. And B is going to go on to E, which is at 1, 3. So notice what changed here. -4 turned into 4, -1 turned into 1. So here the X changed signs. All right, checkpoint. Tell whether the gray figure is a reflection of the black figure. If it is, tell the line of reflection. All right, so you're going to say yes, or you're going to do this now. You're going to say yes or no. If you say yes, did you go over the x-axis or did you flip over the y-axis? That's what they want you to do. Determine the number of lines of symmetry. All right, remember I told you these are perfect fold lines. So where could I fold this perfectly in half? So for this, well, the obvious one is here. That's perfectly in half. Or we could also fold it down. But for a square, you could also fold it. Look at this half of a triangle over here. Look at this half. Those are the same. So we also could fold it this way, because look at this triangle is the same as this triangle. And that is all. So let's see, how many do we have? Here's one line, 2, 3, 4 lines of symmetry. Could I fold this in half anyway? That half isn't the same. That's not going to work, because those corners aren't going to match up perfectly because those lengths are different. This has 0 perfect fold lines. Perfect fold lines. And let's see here, I could cut it in half here. I could cut it in half here. Now, could I cut it in half going this way? Doesn't look like all of these are the same length to me. So I'm going to say no. I'm going to say that this only has 2. Right? 1, 2 lines total. Is the following statement true or false? A line of symmetry is also a line of reflection. So if you look at this, could I reflect this side over this side and have to be the same? Yes, this is true. A line of symmetry is also a line of reflection. Last example. Using a kaleidoscope, 2 mirrors are placed to form a V. The angle between the mirrors is related to the number n of lines of symmetry in the pattern by the equation. The angle is equal to 180 over n. Find the angle between the mirrors. Okay, so what this whole thing is saying is that to find the angle you take 180 and you divide by the number of lines. So let's see, how many lines of symmetry do we have here? We've got 1, 2, 3 lines of symmetry. So we're going to do 180 divided by 3. 180 divided by 3 is 60. These are all 60-degree angles. That looks right. 60, 60, 60 makes 180. There we go. That's perfect. Here, how many lines of symmetry do we have? We have 1, 2, 3, 4 lines. So n equals 4. So we do 180 divided by the number of lines, which is 4, and 180 divided by 4 is 45. Yep, those look like 45-degree angles to me. This is M Cubed, signing out.